Okay. Last week I talked a little bit about periodic functions. Now, a function is said to be periodic if this condition is satisfied. What do we actually mean? This may look a bit alien to some of us, but I think this is alright. An example of a periodic function is the sine function, where you take a look, sine x plus 2 pi is actually sine x. So the cycle repeats itself every 2 pi. Make sense? Or how many times this formula? So in this case, the period is actually 2 pi. Your A, which is the period, is actually 2 pi. Make sense? Yes? Alright? Okay? So an example of a periodic function is the sine function, tangent function, your cosine function as well. All are periodic functions. Now, we're going to use only one example to illustrate this idea. Only one. So please pay attention to example 8. I'm only going to use one example. Okay. Example 8 goes like this. It is given that fx is defined like this. So you have two expressions. This is what we call a piecewise function already. Yeah. So let's take a look at this first. It has two pieces. From 0 to 2 it is defined by this. 2 to 4 is defined by 5 minus x. And that fx equals to fx plus 4 for all real values of x. So now you have quite confusing. If the first time you see it, it may look a little bit confusing. But let's try and break it down together. First, what is the value of f1? Now, since 1 lies between 1 and 2, so we look at here. I don't think it's a big problem. It is just 1 plus 1, it is 2. That's easy. I don't think it's a big problem. Now, what is f15 then? Now, you cannot take a look at this expression here yet, because actually 15 doesn't fall between 0 and 4. You cannot see this one or this one. Cannot. But if you take a look here, fx is fx plus 4. That means the cycle repeats itself every 4 units. Does it make sense? Yes? So f15 is actually 11. Make sense? Yes? Make sense? Because to minus 4 now. Correct? Because the cycle repeats itself every 4 units. So what's so good? Now, but if you take a look at f11, you still don't know the answer because f11 is not here. Then it must be f7. Very good. I heard some of you say. Still not good enough. Still not good enough. It must be equals to f3. And now it makes sense. You know why it's like that? Yes, because of this condition, fx equals fx plus 4. Now you think analogously. If you don't get it, think. Can I say sine, let me see, 7 pi over 3 is actually sine pi over 3. Does this make sense? Make sense or don't make sense? Because I minus 2 pi. Same one. Correct? I minus 2 pi. Just like sine 262 degrees is sine 2 degrees. Make sense? Yes? Alright, so this is the same thing. Because f is a periodic function with the period equals to 4. So this equals to this equals to this. Now we are good. What is f3? Now we have to take a look here. You have to take a look here. 5 minus 3 because x is between 2 to 4. Okay. Therefore, the answer is 5 minus 3, which is all okay. All good. Now, what is f? Then what is f21? Do we need to keep? Yes, we should still minus 4, minus 4, minus 4, minus 4. And I think it's not difficult. F21 is F17. I don't think I need to write too many things. It must be F1. Very good. 1. Sorry, 1. What is F1? F1 is 2. We calculated earlier. So, challenge, do you know how to calculate F198? You write on your own, I don't want to go through. Okay, as long as you know, minus 4, minus 4, minus 4, minus 4. You can do it on your own, I'm sure you can do it. Alright? Now, next part. Sketch the graph. And now this is the challenge. Sketch the graph. Again, I repeat, for this periodic function, there is only one example. One. Only one. So you better understand this properly. So, what? Is it sketch for you? Wow, very bad. I should have left it blank. But never mind. This is not complete. How would I sketch this graph? Actually, I would sketch this graph like this. I will only sketch it from 0. Wait, because I start off with this, I will only sketch from 0 to 4 first. How? Here is 4. So, I need all of us to do this. This, you need to highlight this part. Highlight this part with a different color. And then you tell yourself, sketch this first. You are only going to sketch from 0 to 4 first. Okay? You highlight this part and say, sketch this part first. How do you sketch this part first? You look at the piecewise function definition. From 0 to 2, it is defined by x plus 1. Correct? From 0 to 2, it is x plus 1. So, from 0 to 2, this graph is y equals to x plus 1. This is just notes for you, all of us. Okay? What is the x plus 1 curve? Sorry, it's actually a straight line. X plus 1 is a straight line. So, you can tell that this is a straight line with gradient 1. X plus 1 is 0. When x is 0, y is 1. Correct? So, we have to label this one. 0, 1. This one must label. This is part of the solution. This is part of the solution. Better write this. Okay? And then, when x is 2, y is 3. This is also part of the solution. This also must label. Yes? Now, when x is between 2 to 4, it is defined by another function, another straight line, which is y equals to 5 minus x. 5 minus x is a straight line with gradient negative 1, like this. And it so happens that when x is 2, the y is also 3, so it coincides. It is a continuous graph, like that. And it's downward sloping. And it's only defined from 2 to 4. So 2 to 4, you substitute 4 in here, you will get 1. So this coordinate also must label. This is 4, 1. So far so good. So we are only going to sketch this part first. But the question very clearly says that we need to sketch all the way from minus 4 to 8. Just like when you draw the sine curve. When you draw the sine curve from 0 to pi, from 0 to 360 degrees, you know how to sketch. What if they ask you to sketch a sine curve from 0 to 720 degrees? You just repeat the cycle, right? So now, same thing. You know this part already, and you know it's a periodic function. The period is 4. 4 is the period. You just copy and paste this one to the next cycle. Exactly the same. So therefore, you copy and paste, you will get this. You will get this next part. Then you copy and paste, you get this next part. Now what I do want to emphasize is when you sketch the curve, you must label the important points. What are the important points? All these are important. That means you must label this one, you must label this one, the coordinates. You must have the coordinates. Can you do me a favor? Now that I have labeled these three for you, you label this on your own. On your own. And knowing that the period is 4. Okay, quickly check answer. Now, this is a translation. This is the period is 4 units. So therefore, this must be 6, 3. This must be 8, 1. This must be minus 2, 3. Sorry, there's no bracket here. And then this is minus 4, 1. All okay? All good? Very good. Okay. So now where this is what the Cambridge examiner said, the coordinates of the endpoints, these are endpoints. This is what we call endpoints. This is the endpoint. Because the question asks us to sketch from minus 4 to 8. So these are what we call endpoints. Okay? And where the curves meet, that is, this is one distinct curve, this is another curve or straight line, where it meets, this one must be labeled. This is one curve, this is another curve, where it meets, it must be labeled. So everything must be labeled. Yes? All good? Very good. Alright. Only one example done. Now we come to another concept called parametric equation. Wow. You see the words, you also scared. But never mind, let me pause the recording.